Okay, this is going to be from lesson 12.3. Here are the answers from lesson 12.2, page 863 to 865, numbers 15 to 48, multiples of 3, number 50, and 56 to 60. And so I'm going to leave these up here just for a moment so that you can see these answers so that you can check them so you're good to go. All right, so there's through 30, and here's 33 to 48. Should get you through those. And 50, 56, 57, and there's 59, and number 60. All right, so we're going to look at simplifying rational expressions. And for this, we're going to do examples 1, 2, and 3 are for the assignment on Tuesday. And 4 and 5 will be for Wednesday. So we're going to go ahead and I'll do examples. I'm going to do all of them. We'll just do, we just need to stop the video then and Wednesday, or on Tuesday, and then show it on Wednesday. So simplifying rational expressions, they want us to find any excluded values for each rational expression. So first of all, when we're talking about excluded values, we're talking about when the denominator is equal to 0. So if we have an excluded value, we're looking for when the denominator is equal to 0. So for letter A, that means we can take the denominator and we can say g plus 4 equals 0. And if we solve that, then we'll get g equals -4. So when it asks me for an excluded value, I will say the excluded value is -4. Now in letter B, then you want to make sure that when you do these excluded values, that for letter B, because the denominator is a quadratic, you need to actually factor that also. So I'm going to set it equal to 0 again. So x squared minus 15x equals 0. And then we need to factor this. Since it has two terms, and both those terms have an x in them, we need to factor out x. So we get x times x minus 15 equals 0. So in this case, we have zeros at 0 and at positive 15. So then I will say the excluded values are 0 and 15. Okay. Excluded values are 0 and 15. So in each case, when they ask for excluded values, we need to look at when is the denominator equal to 0. If it's a quadratic function, the denominator is, then you're going to have to factor it also. So you're going to have to pull out those factoring skills you have once again. So for letter C, y squared plus 5y plus 4 equals 0. So if we factor this, what are the factors of 4 that add up to 5? So that would be y plus 4 and y plus 1. And so our zeros here would be -1 and -4. So we'll say the excluded okay, trouble spelling. The excluded values are -1 and -4. All right, those worked really well. Okay, so for excluded values then, we're looking at when is the denominator equal to 0. Now, for example 2, they want us to simplify rational expressions. And so to do that, we're going to factor first, if we can factor, and then we're going to cancel the like factors that they have. And then they're also asking us to identify any excluded values. So what makes the denominator equal to 0 once again? And when we're doing the excluded values, even though we're going to be doing some simplifying, the excluded values refers to the very first or the original problem when it's in factored form, not the simplified version of it. So for letter A, here we have 2r to the 4th over 14r. So since these are both monomials, then I just need to simplify the similar thing. So we have 2 over 14, which reduces to 1 over 7. And r to the 4th over r, we have 4 r's in the numerator and 1 r in the denominator, so we can cancel 1, so we have 3 left in the numerator. So we have r cubed in the numerator. So I could write this as r cubed over 7. And when I identify the excluded values, I'm going to say then that x cannot equal, or in this case r, sorry, it's not x, this is r, we're using for our variable. So r cannot equal 0 because that would make the denominator equal to 0. So I go all the way back here, look at the 14r, say, okay, what makes that equal to 0? And it is 0 because when I multiply 14 times 0, I get 0. All right, let's look at letter B. Okay. Once again, we want to factor if we can. So if we look at 6n squared plus 3n over 2n plus 1, we look at the numerator. Okay, what do 6n squared and 3n have in common? And they both have 3 and n. So we're going to pull out 3n. And that leaves us with 2n plus 1 over 2n plus 1. Now, some of you might want to go back to this original and just say, oh, well, I can factor that n and that n out there. And you can't do that. To be able to cancel, you have to have common factors. And those are not factors because there's addition going on between them. The only way we can have a common factor is if there's multiplication. So in the numerator here now, we have multiplication going on. 3n times the quantity 2n plus 1 over 2n plus 1. So we can cancel these two because they are a common factors. Okay? The denominator, since that's the only thing that's there, that whole thing is a factor. And then I have it in the numerator, and so those I can cancel. So my answer here is going to be 3n. Now, they want us to identify the excluded values, and we're going to do that by saying then, since this case our variable is n, so we will say that n cannot equal, and it can't equal whatever makes the denominator equal to 0. So I have to solve this equation. So to solve this equation, we would subtract 1 and divide by 2. So n cannot equal negative 1/2. So the answer to this, when I simplify it, is equal to 3n. But I got to identify any excluded values. My excluded value here would be negative 1/2. That's what makes the denominator equal to 0. So I'll say that n cannot equal negative 1/2. Okay, so one more. So here we have 12p over 3p minus 2. So does this fraction, this rational expression, does it have any common factors? Can I take 12p and 3p minus 2 and can I simplify it? And the answer is no. This is all you can do, is write this problem down and say that n or p cannot equal 2/3. What makes the denominator equal to 0? Because yes, we have a p in the numerator and a p in the denominator. The problem is that in the denominator, it's not a factor. We have a difference in the denominator. There's subtraction going on. There's not a factor. There's no multiplication. So you cannot do any simplification here at all. And here's how you can check it. If you do any simplification, you can go to your calculator, if you have it. Or you can pick a number like 5 and stick in there for your value of p. So for instance, let's say that you wanted to cancel the p's. Oh, well, wait a minute. There's a 12 over 3p. So maybe this is 4. Oops, let's not use that color. So maybe I say that this is 4 over negative 2. Oh, that's equal to negative 2. All right. So if you think that equals negative 2, then put a value in for p to check it. And so if I put a value in for p, let's say 5, for instance. So we get 12 times 5 over 3 times 5 minus 2. Now, if that's correct, then this should equal negative 2 when I simplify it. Well, 12 times 5 is 60. 3 times 5 is 15 minus 2 is 13. Does 60 divided over 13 equal negative 2? I don't think so. So the simplification of this is not correct, and so you have to be careful there that you don't simplify things that cannot be simplified. Example 3. Okay, a little bit tougher ones. So we're going to have to really do some factoring because there's going to be some trinomials involved in these, and you got to be very careful when you're working with these. So here we have x plus 2 over x squared plus 5x plus 6. So the first thing we're going to do is factor. And notice it doesn't say in this problem list the excluded values. So we're not worrying about excluded values. We're going to assume that for every value of x, it does exist. So the numerator, we're good. Can't factor that. The denominator. What are the factors of 6 that add up to 5? That would be 3 and 2. So x plus 3 and x plus 2. So now I have a common factor in the numerator and the denominator. Now, here's a situation you have to be very careful. Remember that I'm saying, okay, how many times is x plus 2 going to x plus 2? Well, it goes into itself one time. Don't forget that. which this means then that I have a 1 in the numerator and x plus 3 times 1, or x plus 3 in the denominator. Okay. So there's a 1 in the numerator here. What some of you will do when you have a problem like this is you say, oh, those things cancel out. It just equals x plus 3. But once again, you could check it by putting a number in for x in the original and in your answer and see if they work. If they do, great. You probably did it right. If they don't, then you made a mistake. Okay? Let's look at letter B here. Right, so here we have a quadratic in the numerator and the denominator. In the numerator is the difference of two squares. So that would be w plus 2, w minus 2. Okay? It hasn't been that long since we did factoring, so hopefully you can still remember that so you're factoring well. In the denominator, what are the factors of 12 to add up to 8? That would be 6 and 2. All right. So now we have in the numerator and the denominator, we have common factors. So I can cancel the w minus 2's. So then I'm left with 1 in both of those spots. So I have w plus 2 times 1 is w plus 2 in the numerator and w minus 6 in the denominator, which gives us our answer. Okay, so those are the only ones that you're going to need for Tuesday's assignment, which is page 870, numbers 1 through 16. And then when you go over to Wednesday's assignment, you're also going to need example 4. And let me see if we need 5 or not for that. Let's see here now. Nope, we don't. Didn't do it. Okay? All right, so example 4 here says simplify each rational expression if possible. And so this is at time 1744. So that would be the time that you're going to want to start it on Wednesday so that you can see this other example here. So it says to simplify each rational expression if possible. Now, the one thing that's different about these problems that we're going to look at here in example 4 is that we have opposites. All right? So for instance, let's do our factoring. So it tells us, number 1, factor, identify opposite binomials. So we factor the numerator. What do 5x and 10 have in common? All right, they both have a 5 in common, so I have 5 times x minus 2. Now in the denominator, we have the difference of two squares. We have 4 minus x squared. Well, that's 2 minus x and 2 plus x. Now, we have opposites here. We have x minus 2, 2 minus x. They are the opposites. So to change them so that they're the same, I have to multiply by -1. And so what I'm going to do then is I'm going to pick one of them to rewrite. And I like to work with the numerator, so I'm going to rewrite the numerator. So I'm going to rewrite the numerator as 2 minus x. So now it looks like the denominator. So I have a 5 out here, 2 minus x, 2 minus x, and 2 plus x. Okay? Well, the problem is I can't just change that around. Okay? There has to be a reason for it. And so what I'm going to do then is I'm going to put a minus sign out front here. Because what happens is if I was to distribute that minus again, it would change the 2 to negative and the x to positive, which would be what I originally had. So I can change the signs, and so there's actually two ways to think of it. I can think of it as multiplying by a negative, or we can think of it as factoring out a negative. So if I had x minus 2, and I factor out a negative, so I say negative 1 times, well, what happens? If I take a negative out of the x, the positive x, it becomes negative. And I take a negative out of the negative 2, it becomes positive. And so you can think of it either of those ways. Now I have common factor, 2 minus x, 2 minus x. So my answer is negative 5 over, and you could write it as 2 plus x, or I prefer to write it as x plus 2. Okay. So if you have opposites, and there's two ways to think of it. One way is we can think about factoring out a negative. Okay. Factoring out a negative, which I showed over here. Or you can think of it as, okay, I'm going to rewrite it as the change of signs and just put a negative in front. Those are the two things, same thing, same philosophy there. Okay, let's look at another example. Now, remember, the first thing we're always looking for is, what do they have in common? So look at the numerator. These two both have a 6. So we have 6 times 3 minus r. Now in the denominator, these all have a 2. So first thing I can do is factor out that 2. So I'm going to factor out that 2 right here. T squared minus 4t minus 21. It's t. Now can I factor that? So we have 2 times, and this would be, let's see, t minus 7. We have r's and t's. T minus 7 and t minus 3. Okay, well, let's use t. So we'll make that r in the numerator a t also. Okay, this is supposed to be t. Okay. Now, if you notice, we have 3 minus t and t minus 3. Those are opposites. And so if in the numerator then, I choose to factor out the negative, so it becomes negative 6 times t minus 3 over 2 times t minus 7 find my mistakes here. It should be t plus 7 and t minus 3. All right, so now I can cancel out the t minus 3's, have 1 in both of those places. And I can also divide by 2, so 2 goes into 2 once, 2 goes into 6 3 times. So in the numerator then, we have negative 3, and in the denominator I have t plus 7. And there's my answer. Okay, that one's kind of a mess because of the r's and the t's, but hopefully you understand the main point there, that we want to factor first. If you have opposites, then we're going to make the whole thing negative and change one of them to positive, switch the signs on one of the factors so that I can cancel and then solve.